Hey guys, how's it going? Today, this is a little bit of an earlier stream, um, because I have some things going on later today, and it's Friday, and I still want to get some stuff done. Today I realized that there's a really nice bit of work here that doesn't really take anything else. We have essentially the X carriage, clockwork, the direct drive module. We have the fan module here, and we have the V6 tool head. So, an update from yesterday. The owner of this Voron went ahead and ordered 2 new X rails. So we'll put these Y rails on the Y axis again. We won't swap any rails around. He's getting his replacement rails from Ziltech, which in general I believe those are pretty good quality. So I have confidence that they'll show up well. So probably today we'll just focus on Afterburner and the X carriage and getting that together, and then the stream following that, which will likely be maybe Sunday, because I don't want to overlap with Uber's stream tomorrow. We'll probably put the essentially the X and Y assembly together as much as possible, given that we don't have the X rails probably until early next week. So it is Friday. Yes, thank goodness. Today was the end of the work today could not come soon enough. But happy to be here. Happy to be working on Voron stuff. Let me just go ahead and switch to this camera. So I've increased the brightness here and tried to reduce the contrast some, because I realized that whenever I was holding up these parts, essentially the camera's focusing or doing exposure off this bright background, and the black kind of disappears. So hopefully it's a little bit easier to see this time. But let's see here. Let's just get started with the clockwork module. So clockwork module, let me open up the let's see here. Let me open up the assembly manual. Because I believe I know where all the parts go for the heat sets, which will be the first part, but I want to double check to make sure I don't make a stupid mistake. Let's see here. One moment. Okay, switching over to the monitor. So last time we left it off here with some of the Gantry stuff, and let's see here. Perfect. So here's the Afterburner section. We'll pass the X carriage for a second here and start with clockwork. Again, let's see here. So this page here shows the different heat sets we need to insert. And again, since I am the glorious person who bought the wrong heat sets, I'm going to be drilling out the heat sets like I did yesterday. So I'm going to switch over to this camera, or drilling out the holes. The other thing you may notice, I have 2 separate bags of heat sets. If you remember from the beta, there were some long heat set inserts and short heat set inserts listed. And since I know some of these parts can fit the long heat sets, even though that's not spec, all you need to buy when you buy parts are the short. I'm going to go ahead and put some long in, because if you notice here, I have a lot more long than short, because I've been using them using the short ones everywhere else. So before we get started, let's just go ahead and the one thing I do recommend you testing before getting everything together is checking essentially the fitment of these 2 parts. If you were unlucky and you received a very early kind of beta version, or not beta, but one of the first release versions of this part, essentially whenever this lever comes flush with the rest of this part, you'll actually notice it starts getting pushed upwards. In this case, we're fine, but if we look, it's probably going to be really hard to see. We'll see if we can do it though. Yeah, this is probably not going to focus. But essentially before there was a slight interference where these two parts would not mesh properly. So the issue with that is since essentially this piece is spring-loaded to compress the filament, if it doesn't mesh well with both parts, then essentially it will stay open more than it's supposed to. And if that happens, then your filament's not going to actually get extruded because there's nothing gripping it. So it's just one quick check. The other thing to check before we get too far here is these parts print well, but I always go ahead and drill out the filament path from this side and from also the bottom side here, because it's better to have a nice smooth surface there. If for some reason your overhangs weren't the best, it's better to make sure this is perfectly smooth, because the pancake stepper doesn't have a ton of extra torque. It has plenty, but if there's a lot of extra filament restriction there, then you don't want that. So what I'm going to go ahead and do, and I'm going to pull up the calculator here just to double check. Okay, so yeah, so I'm going to grab a 5/64 inch drill bit, and again, I do not have a metric drill bit, but that is 1.98 millimeters, so it is slightly bigger than your filament, and it will allow the filament to go through freely, but it is not too big enough that there's lots of extra slop. Okay, so all I'm going to do here with this is I'm just going to, there's actually nothing really, so this is actually pretty good right now. This side is a little more restrictive, and again, most likely your part's going to be fine, but if you over extrude it or anything like that, it's better just to double check and make sure that you can essentially see. I'm looking through the part here and I can see the table all the way through it, and then there's no burrs or anything like that that are stopping the filament from going through. I don't have a piece of filament here with me at the moment, but it's always handy to just slide it through as well, just to double check. So there's that, and just a test fit of these parts just so you see how they go through. This is the shuttle here. The small piece fits in there. Then here's the latch right here. So there's all those parts, and then this is up here right there, like that. And of course, since there's no screws or anything like that holding it together, that's generally how it ends up. So there's a lot of heat sets in this. So let's get started. Let me preheat let me plug in my soldering iron. I did have it preheating, but if you don't plug it in, it doesn't matter if you turn it on. It still won't work. There we go. Now it's heating. Okay. And again, I'm going to do the same thing I did before with this drill bit because my heat sets are too large. Let's see here. Okay, so let's get started. I'm just going to reference the place, not that. Here again, we'll get started with this piece here. So if we jump back over to the overhead camera, that is these two holes right here over on the side. So for some reason that looks strange. Okay. Yeah, I just wanted to double check to make sure that I was doing it right. So let's, oops, sorry about that if you heard that. I'm just going to go ahead and drill this. And then drill this. Okay. So that's good. And then on this part right here, there are two on these back corners. So I'll drill those out. Okay. And then there's also one right here on the front side. And that one's a great one for the long heat set insert because it's a pretty deep area there. And then the final one is on this side. That's to retain the cable cover. Oh, that's funny. Yeah, I always set these. I've been setting up the last 2 live streams with just a short schedule. They are scheduled, but they're delayed, or just 10 minutes in the future. It's because sometimes I don't know when I'm gonna start it. But if I do give you guys a few minutes to join, then there's someone here when I start, and then there isn't the awkward 5 minutes at the beginning where I'm just staring at the screen. So okay, so we did this part. So those 2 parts are done. This one is for the cable chain, and this is there's 2 different versions of this, and actually this is a really interesting part because if it'll focus, you can even see, even with it not focused, you can see that ringing there. I do not think I printed this with this part with input shaper, so you can tell that there is a decent amount of ringing there. But some of these parts, there isn't a lot of ringing. And actually, I'm going to take a short minute here to talk about ringing. I know it's interesting to me. We'll see if it shows up at all. These parts all kind of look. I was going to do a quick show of different settings, but since these are all black, unfortunately, I do not think it's probably going to focus for me. So you won't be able to... maybe I get lucky. It's a roll of the dice. I wish I could specify where this was going to focus. But, yeah. So the one thing about these AB drive mounts is that right around the base of these parts, there are some ringing features that you can see, and then depending on how these parts fit together, it can be a nice tuning test to see if your settings are good. And ringing does not affect performance, no. It just looks a little uglier, but it's not bad. Just drilling out these holes here. Okay, those are nice and clean. My table is now dirty. This one gets a heat set right on the end there, and that is so your thumb screw goes into that heat set. And of course this one's probably not going to work very well because I don't have a lot of torque on it. And then this one doesn't need a heat set, and this one also does not need a heat set. So I think I may have done, I may have completed all of these. So I'm just going to brush this off here into my hand so the dog doesn't eat it later. And then here, okay, so now we're ready with these parts. Let's see, let me grab the BMG clone from the parts bin. One thing here, this is a Go 3D clone, but if this brand on Amazon actually does often pick up Triangle Labs parts, so even if you look at it, let's see if it'll show up. Probably not. But the SKU number right there actually says TLBMG, which I'm assuming stands for Triangle Labs BMG. I bought a Dragon from Triangle Labs and a Dragon from Go 3D, and if you peel off this front sticker, this QR code here behind the sticker is actually the same. So this is definitely a Triangle Labs BMG clone, which is definitely I generally are more comfortable with Triangle Labs than a lot of other suppliers. So it's nice that there's something on Amazon that this can get picked up in 2-day shipping if you need it quick. So let's see here. So there's a few parts here that most of the parts we'll need, but a lot of the stuff we will not. So this part here, it is not screwed together, but we will separate it. Here we need this piece here, which is the kind of main gear. And then we need the idler gear here. And I'm actually going to grab my flathead screwdriver here to help snap this off, because it can get a little tricky, assuming I don't maybe I'll just push it through. There we go. So I just pushed down on the pin, and it slid it out just a little bit. I should have actually pushed the opposite direction. But so there's that. This will have 2 small bearings in it, so be careful about that. And you'll need that pin. And then before we toss these plastic parts here, we don't need this pin, but we do need this bearing right here. So you can get something and kind of just push it out just a bit. Sometimes it will come out on its own with this, but sometimes it doesn't. So. And we can just push this back on there. And then the other part of this, if I can figure out where I put it, right here, has the other bearing. You can see it in there. So this one can, depending on how tight it is in there, it can be a little tricky. Or I'll repeat that. Let's see here. Of course, I've never had an issue with it in real life, but yeah, I just pried it out. So try to be gentle as much as you can, because they are fairly tiny bearings. In our case, they're not really handling any load, but it's still good to be good. So that's good. The one thing you'll note here is that there's a substantial gap between the white gear and the drive bearing right here, and that gap is something we do not want. So what I'm gonna do is I'm going to find my hex wrenches and hope I have the right size here on hand, and I'm just gonna really don't use a ball hex on this since it's a really tiny grub screw, but I'm just gonna slightly loosen that up. And then I'm going to slide this drive gear all the way against the white gear, so there's no gap. And then we'll just tighten it up. And again, it doesn't have to be super tight. There is a flat on this shaft, which helps, but it's generally best to not strip that. Okay, so now we have this with a bearing on that side and a bearing on this side, which is great. Let's see here. And then we'll just test fit. It should fit right in here nicely. It's loose on this side because this is the bearing. So that should go nicely. And then another great question. My soldering iron has finished warming up, so we should be able to put those heat sets in. One thing I'd recommend, which I do not have the lubrication right now, for this, but typically I'll put a very, let's see if I can push them out with this. Okay, so yeah, so this is just a metal part, and then there's these two small bearings. Typically what I'll do is I'll put some kind of lightweight oil on those so it doesn't dry out. Again, there's probably a proper oil there. For my purposes, I grabbed some chain lubrication from my bike finish line lubrication, and it's been working well for me. So, but yeah, so again, drop this in so that the toothed piece of your idler gear fits in there, and then just press down, and it has a nice snap. It spins freely, and again, I'm going to take this out and put oil in it later, but remember to do that. Otherwise, these gears do end up getting dry, and then they kind of seize up after a while, and then you have issues. So that part I don't need heat sets. That one I don't need either. I'm going to stick that off to the side. Clean up my area just a second, and take that off. You've been waiting for your police? I'm assuming that's something to do with some parts. I hope that AliExpress can redirect to your correct address, because if they get all the way shipped back and then you had to wait again, that would not be very fun. It was kind of like my, I don't know how to say it, FISEC, etc. I don't know. The S6 control board. I had been waiting a very long time for it, and then when it arrived, it was essentially crushed. It was pretty bad. All the pins were bent. I think the board was maybe cracked a little bit. It's hard. I forget exactly. But the USB connector was damaged, so I ended up getting a refund. Thankfully, they were one of the few AliExpress suppliers that have return addresses within the United States, so I was able to get that fixed quite easily, which was great. But yeah, I understand the pain of having stuff show up the wrong place. So again, I'm just heating this up, and we'll hope that this one, yeah, this one's deep enough. And then I am pushing down. This one I'm doing on the edge of the table. I'll move this over right here, because if you'll notice, there is a flange right there. So essentially, if you press it flat down the entire part, it won't press the heat set flat. But if you do it on the edge of a table, you can get it. So that one's in. We will do this side one right here, which I believe is going to be too shallow of a hole to get a long heat set insert into. Okay, and remember that they're still hot after you take off the soldering iron, so don't burn yourself, because I have. Again, heating it up until it starts moving. Then before it gets fully inserted, push it in the rest of the way with the edge of the table. Again, this one has that curvature, so I have to use the edge of the table. That one's looking really nice. And again, this looks so much better now that I drilled them out, because for the longest time I didn't realize I had the wrong heat sets, and I was so confused as to why everything was looking like complete crap. Then once I figured that out, it worked much better. So I drilled this hole out just a little bit deeper, because I want to use I think I can use a long heat set there. I really need to order some more. Okay, that one's ready, and I keep touching other heat sets that I put in that are still hot. Will I ever do something like this for electrical wiring? I was actually just thinking about that. And I was, so after we get the gantry installed, really the next thing after running belts is essentially running all the wires for the XY joint to the tool head, all those different things. And that's usually a part that is really, really mind-numbingly painful. And I tried to avoid it as much as possible. And it's, isn't necessarily the most interesting thing for a stream, but at the same point, it is probably one of those places where we don't really talk about much. It's just more like, just do it. So if you think it would be useful, might as well have company the whole time I'm doing it. And you can ask questions or you can do Q&A and something like that. So I'd be sitting here by myself otherwise. So okay, so there's heat sets for that one. We'll do it for this one next, and these. Let me just double check if I can put a longer one. That one's going to be pretty. That'll probably work. I want to put a long one in here and a short one there because I don't want a long one to push this wall over, which may end up causing issues. You're worried more about the mains and underneath the hood. Okay, yeah, that makes sense. So the mains. Let's see. So you're more worried about the wiring everything up under the printer, like the SKRs and the SSR and inlet plug and all that. That's looking nice. Okay. And I'm going to leave this till a bit later because theoretically that is not completely critical. And this definitely, I won't use a long. We're going to use this short here. And yes, the other trick is you can actually remove these heat set inserts if you need to. So if you heat them up and put them in, you can also heat them up and kind of, I won't do it on this one. I wish I had a spare part. But essentially, if you, insert the soldering iron and then kind of wait for, and kind of put a little bit of torque on it and then wait for it to start twisting, you can kind of like fish it out and then reuse them for future parts, because otherwise you're just going to be buying a crap ton of these and that's not really economical. So yeah, so mains really are, yeah, that would be an interesting thing. So guys, after this build, this is just a rebuild from a V2.4 to, or V2.2 to V2.4 gantry. I will be essentially repeating this entire process again with a complete brand new V2.4 build, because I have all the parts sitting over in the room over there, ready to go. So as soon as this is done, we're just going to start over. So yes, I will be doing the that part, but to be completely honest, it might be a little bit down the road. I'm not sure how fast. Put a screw in and heat up the screw. Yep, that works great too. Okay, so we're gonna leave that in there. Again, let's drop this in here. Let us grab this. Drop that there. We're going to go to this parts bag here. How much would you charge for me to build a V2 it's a great question. The nice thing is I haven't built a printer for a while, so this is kind of relaxing. To just like do stuff that's already built and know I won't have to tear it apart right away. But okay, so that's good. Everything's lined up there. Let us see. I should grab the Afterburner motor from the box over here. And if I do not have one, it is entirely possible this build will get lengthened, which you probably can't hear me anymore. So for today, I'll just use a placeholder. It's nice to watch you build. You're the Bob Ross. I can just keep building printers over and over again and talking about the same stuff. Your videos will come sooner than Ollie's stuff. Yeah, that'll be. We'll see how that goes. This week it's been fun because I kind of want to just get this done because he's been waiting for such a long time. So, and also I'd be working on it by myself anyway, so I might as well just stream it now that I have everything set up. So this is not the right motor. It is a HM17HM08 1204S. It is almost the same form factor. So we'll use it as an example because that is what I have on hand right now. Today's Amazon shipment was some new LED lights to go on my umbrellas to hopefully brighten things up a little bit more. I got a cheap fluorescent kit that was nice, but it looked green and they were not very bright. So let's see here. So with this one, again, this is not the spec motor. So if you'll notice, it actually does not have a flat on it, which is not the end of the world. It's not great. It's not terrible. But we will use it right now anyway. So let's see if this is the right size. Oh, it's too small. That means this size is the correct size. Okay. So for this, let me just see if there's anything in the manual that specifies where or how far on this shaft it should be. So it doesn't specify exactly the position of this gear. What I did here is I didn't have it quite up against this black part here. And actually, look, I have done it the wrong way around. So don't follow me. That's why you read the manual. So this part actually has to rotate around 180 degrees. But I'm not going to have it completely flush because then it would be grinding against this, or at least rubbing it. So I'm going to move it out just a hair and then I'll tighten it down. The thing I love with seeing your comment kit about almost done with your 2.1 build is that there's so many people that have started these builds, and it is a marathon to get one of these done. It is not like a single weekend type endeavor unless you really do it a lot, and even then, you know, it's just exhausting. So it's awesome seeing you finish up a V2.1 after, you know, all these. I guess it's only been a year or two. Time flies since V2.1 came out, but it's great. It's great seeing that you're still at it. Okay, so for this, we need to put the this motor piece on the stepper motor, but you want to be aware of what direction this motor is going to be. So, nice. I have not ordered a keyback for the switch wire, But so with this, you want to make sure your wiring is exiting the motor in the correct place. So essentially how this is going to work is this chain mount is going to be on the back, and then the chain is going to loop around. Essentially the wires are going to go back and around. So typically I'll line up my wires off to the side right here so that they can go easily into the cable chain. So if you have it pointing downward, it may rub on the it may be fine, but it's just, again, there's good things and bad things. So I need an M3x8 for here. So you'd think there would be a ton of M3x8s here, but for some reason I do not see a bunch of them. Or else my mind is playing tricks on me. The other thing that had been staring at me in the face was these idlers for the XY joints, which I was just about to message him and say that he needed them, but here's a pack of 5. So we can put those on the XY joints in a bit. And I believe this is the wrong length for, I think this is, let me grab the calipers. I did learn from last time that I should get the calipers up here. If I can actually get the, yeah, that's a 12, okay. It's, right here, I bet there's some here. Perfect. Yeah, the V0 is really tricky. I put my one that I had and then sold. I put that together without the manual, or maybe the manual was in progress, I forget. But it is tricky. And I ended up going ahead and I sold it to another one of the Voron admins as a kit and shipped it out west. And sometimes I regret doing that, but I'm going to be busy with building printers here for a little while anyway. So, okay, so that's all set. And then we can marry these halves together. Depending on how this is, since this is slightly longer at the end, we may need to just go ahead and pull this out and then essentially mount it to this side first. And I believe, so the one thing here is that you want this tooth engagement here between this and this to be kind of a happy medium. You don't want it to be too tight where they're like physically like in compression, but you don't want it too loose where like this gear would flip back and forth. So yeah, so this one actually seems pretty good right now. There are some slots up top that we'll be able to adjust the alignment in a little bit. So that should just kind of pop together and fall out. So there's that. So that's all together apart from the, I'm just going to check this white gear to make sure everything works. Yep. So this is together apart from this, which goes around the other way. So now I just need a bunch of, I believe, M3x30 socket head screws. So how is the Magic Studios V2 kit? I've actually been pretty impressed so far. You know, the only thing I've done so far is, let's see here, let me just jump over here. Yeah, the only thing I've done so far with the Magic Studios kit is essentially take it out of the box and look through the parts. But, you know, there's some things that, you know, I won't know until I assemble them. But there's a lot of things that look great. I think the The stepper motors aren't the OMC ones. They're some other brand that we'll see how they work. I've heard rumors also that they're working on he's working on a possibly an LDO kit, which would be good for that. What else? I was impressed that one, he included the panels at all, and two, that they were polycarbonate, which is nice. Nice upgrade over ABS, or not ABS, acrylic. And that he included the back and deck panels and stuff like that. So we'll see how it goes. It's a big deal to be able to buy everything essentially from one source. That's a huge. Again, if I had that available back when I was shopping for my Folgertech FT5, sorry about that, I probably would have much more readily gone ahead and bought a V2. So let's jump back to, let's see here, where are we? So we've done that. Okay, so we need 3 M3x30 screws. And I will hunt those down here. And thankfully this time I have my, sorry, I keep bumping the microphone. Thankfully this time I have my caliper so I can kind of measure these and see if I'm in the ballpark. And yes, I am. Perfect. So we'll drop that through. How about this is also the same length? Yep. This is golden. And this one here through too. So there's that. Then we'll tighten that in, just kind of loose now, just until it's a little snug. Okay. So you'll note that this screw actually sticks back through the back plate there, and that's fine. That's actually how it was intended, because otherwise, if you wanted a perfect screw there, you would have to get a M3x25. And that would be the only M3x25 screw you'd have, which would be ridiculous. So what we did instead is there's actually a small cutout right here on the X carriage, so that'll work. Okay, so there's a clockwork. We'll just do a quick test here. It feels, so again, this should be able to move forward and backward just a little bit, and it'll float around to align with the filament. And then as well, just note if you're spinning this and for some reason sometimes it feels like it's catching, make sure that your wires on the end aren't touching. In this case there's not a connector, because if they're touching, then essentially the coils are shorted and it will have extra resistance. But if the wires aren't touching and there's still resistance here, just make sure that there's nothing that's catching or anything like that, because that would show up as essentially it extruding or stopping to extrude randomly, which would really make your life miserable. So I'll put that off to the side. Here we will grab this, and this setup here again. This one does not actually have any heat certs in it. Am I right? Yes. So we'll go ahead and install this fan. So in this case, we actually take off this front. And the easiest way in general to do this is just grab a flathead screwdriver and just kind of try to pry underneath here. Like that, and then just work your way around. Like that. So that pops off, which is great. We don't need that. And then this spins freely. It's centered. It doesn't wobble. All those things are good. And then the last thing here is when this goes in, this wire has to come through the back. And if I remember correctly, depending on, yeah, this part actually might be updated. Maybe it won't. It depends on your fan. You may be able to get away with this and you may not. This one kind of feels like, yeah, I'm going to have to snip this little piece off, which is a little unfortunate because the strain relief is, it is nice to have, because these wires, especially down here where they're soldered to the PCB back here, are quite fragile. So really be careful. Actually, I have a better tool for that. 1 second. The problem with having red parts and red handled tools is everything kind of blends together. But I'm just going to snip this little tab off here again, that is holding the wires in, and just being careful to not actually snip the wire itself. So that broke off really easily. So then again, we can route this down through and align this. And it should, yeah, a dab of hot glue on the wires, that would definitely be a good idea. Assuming I had a hot glue gun, which I do not. Maybe that's another purchase to make. And then you just want to make sure all the surfaces here from the duct line up nicely with this part. So there's that. Then here on the front section, this is just kind of a press fit. And depending on your printer or a part, it may fit tighter or looser. VHB type would also be a great idea. And then the thing here is that this wire here will need to basically, let's see here. So all this will fit together. So this wire needs to come back through this slot right here, which is nice. There's a slot. And then this will sit down on top of that, and everything will fit like that. So we'll grab the screws to hold this back piece on the front. I don't have a piece of filament right now handy, but essentially with that, you would just fish the filament through the hole there, line up the parts, and then that'll be your kind of hinge there, which works well. So I'm going to switch over to the monitor here for a second. Yeah, see, that's where it shows the filaments sliding through those as a hinge. So it is M3 by 16. So let me find that with my trusty calipers. Found two. Well, I found a 20. If you have an earlier version of the, now I'll jump back over to the overhead camera. If you have an early version of this part, you may have heat sets in the red section, but on the later versions, those were a pain. So we do not use those anymore. So in this case, these will just thread into the plastic on the front. You may have to press just a little bit for them to grab and start that thread. And again, since this is a plastic threaded part, you want to make sure not to tighten it down too hard. You don't want to strip it out. So just be careful about the torque you use again. As long as everything kind of is lined up here, all the seam looks good, which it does there, then we're solid. And again, when you're routing this red wire would come up through there, and then it comes up through this back channel, and then out the side where it can go to the rest of your tool head. So since we're there anyway, we might as well go ahead. This will come on like that. And I need some M3x30 screws, which I believe I have some right over here. And again, this isn't the best. Thankfully, it's not the best that I don't have that piece of filament, but we do what we have to. Fortunately, at least with the 4010 blower on the front, the axial fan on the front, there's really less of a risk since there is still a strain relief on that. So tighten that down, just snug. And that looks really nice. Let's see here. So, and again, in my case, I would take off that logo because it looks ugly, in my opinion. So that's that. We have that piece. Now let's go ahead and do the x-axis. So this is fairly simple. I will actually worry about those later when we're doing the belting. But for now, we do have some holes that need to be, or two heat sets here, both these bottom ones here. So I'm going to go ahead and drill those just a little bigger. Okay. So those are working nice. And then also we're going to need three, or actually I'll put in the heat sets first. I think I can use the longer ones here. Use out some of those. So my soldering iron's still good. Actually, I always like it when I can kind of prep these a little bit. Yep. Okay. Okay. This looks really nice. I'm going to go ahead and grab 3 M3x30 socket head cat screws. One, two, three. And then we're going to need 3 hex nuts as well. 1, 2, and 3. So with these hex nuts, they go on this side. And depending on how your kind of part fitment is, sometimes it's nice to use a larger hex wrench to kind of push them into the holes a little better. And we'll just go ahead and line these up here. and let them drop out. I'm going to put that there. I'm just going to start with one for now. Okay, then I'm going to bring that like that. And then this next one here, I'll do the bottom center one. Yeah, so there's a few different, so the question is, when you attach the afterburner to the underneath rail, does it need to be tight? Some people suggest you mount the afterburner and then with the bottom rail loose, yeah, adjust it. So yes, I will be able to show that in a future video, but for now, since you're here, essentially what I end up doing is, yeah, you move it left and right to find the sweet spot. And as I'm going along the rail, I don't really have a good extrusion, but as I'm going back and forth, I won't tighten one of the screws unless the carriage is essentially right next to it. So that essentially makes sure that everything's located together. Also, I would always have these 4 screws tightened to your front rail, and these 4 screws tightened to your bottom rail. But you can leave this screw a little bit loose because this is supposed to kind of move around slightly. Yeah, but that's generally my suggestion. But it does take some work to get those aligned properly, and if they aren't aligned properly, you can get binding, which is obviously not good. So I just put that last bottom M5x30 through there. So that's good for now. We can always do more later, but that's what we need to do for now. And then, let's see here. I'm going to go ahead and I'll worry about those in a bit. So that's done. This will, as long as I'm going to break this, I swear. But for the sake of the YouTube stream. Here we go. So that goes like that. And then I'm going to get, there are actually 2 sizes of screws. One is a M3x20 that goes on the bottom side in this view, and then an M3x30 that goes on the top. Yeah, per your question, getting the gantry to not bind at all when it's moving around, and getting the bearings to move freely, that's probably one of the biggest kind of places where you should spend time to get it right. Okay, so okay, so here's a 20. So here we're going to put the 30 there and the 20 there, and then tighten those, hopefully. So the reason the 30 is longer is it actually goes through this motor mount and all the way to the kind of main section of clockwork. So that's tight. And then on this side, this screw only goes into this back section here, so it doesn't need to be as long. So there's that. And then yeah, I did that one step too soon. But we will do that in a second here. For now, we're going to take a step back. We have the tool head here, and we have the old tool head here. We need to get the V6 out of here quick. in order to be able to install it into that. So we'll go ahead and disassemble this. I need to find my other M2.5. They're always running away. Okay. So I can, there's that. And this can come up like that. This is the frustrating part about, or one of the things that is less nice about V2.2 is that each tool head has not only the hot end, but it also has all your fans as well. So there's a lot more wiring, and also depending how high quality. Okay, if I dropped out there a bit, hopefully I came back. It said it lost connection, but it's back. So sorry about that if you lost it for a second. But yeah, so depending on how expensive your fans were that you bought for V2.2, it could add up quickly. Like if you were getting $15 cooling fans and like a $10 hot end fan, you know, plus your hot end itself, that could add up quite significantly. Versus now, it's literally just the hot end, heater, and thermistor, which is nice. But yeah, depending, so I started printing on my 2.4 parts the other day. Estimated total is 140 hours. Yeah, depending on your printer and depending on your print speeds, you know, it can take a considerable amount of time to print these parts. And that is one of the reasons why PIF is kind of a thing and why it's really nice. Again, I mentioned, I think, in a previous stream that the owner of this printer has some friends with Prusa printers, which are great. No discussion there. Prusas are great. But the one thing that I did show him was that essentially, if you're printing the A/B drive modules, so just the 4 black parts, or the 4 main parts that aren't really that big, but you know, they still take a while. There's a lot of surface area there. I use the exact same layers and infill and walls and all that, and then I use Prusa's generic ABS speed profile, and I used just essentially the Voron profile eye print width, which is very similar to what Doc uses for his PIF parts, and it was essentially half the time. So I think it was like 8 hours versus 4 hours, give or take a bit. So, you know, that adds up. If you know, you have the time, or like a friend, I was printing face shields earlier on this year when there was a need, and you know, a friend with an ender was, you know, would print like one face shield in like 7 hours on an ender, and I was printing like 4 in like 6 hours or something like that. With I was using a 0.6 nozzle at that point. So not all completely apples to apples, but you know, still. I'm gonna cut off these fans. Okay, so here's the hot end, and I will cut off this fan as well. I'll have to do this wiring here in a bit down the line, but for the sake of today, I'll leave it as is. The one thing, if you were paying attention and could see it on the stream, this was actually wrapped around in front of the hot end, where the probe is right behind it. Actually, that's a good point. Let me grab the probe. Assuming I can actually find it. It's around there it is. It's literally right in front of me. So the probe. So essentially, when you're installing this, if your probe is here and your hot end wires are up here, your probe and your hot end are essentially right next to each other. But if you route your wires for your hot end so they're between the probe and your hot end. It's not a lot of extra insulation, but it is a slight barrier, especially if you don't have a hot end socket. You do get a little less radiation there, and it's a little bit of insulation. Who knows? But these, depending on your supplier for these probes, some of them are made out of different materials, and a lot of the cheap ones I've gotten have kind of melted at certain temperatures, and that's been annoying. But here we have some more heat sets here. So I'm going to wrap up this stream here in just a minute. Essentially, once I have this tool head on and the Afterburner together. So if you have any questions, feel free to ask them. Again, here I'm going to use long heat sets up here. Again, just because I have them and I know they fit. My opinion on the Omron probe versus the $3 probes from AliExpress. That is a great question. I'm glad you asked. So, I have had the PL08, the PL05, and the Omron probe. I have had Photech probes and the Zongdi probes like this. And certain ones, if it works, it works and it's great, and if it fails and it's bad. That's kind of oversimplified, but so as a reference, one of the PL08s that I had, one good test is to run your, so you can use probe accuracy, which does 10 probes, and you can like send it a bunch of times as your hot end and bed are heating up. And you can see how your probe sense distance changes over time as the temperature of your enclosure and the probe heats up. So that's a good test to see how much fluctuation your probe has, how sensitive it is, essentially. So the PL08 I had back in the day, which I don't honestly remember where I got it, but it was one of the cheap ones for sure. It shifted around a lot. It was quite considerable. But then the PL05 I got, those seemed to be pretty good, so I used those for a while. And then I heard about the Omrons, and I was like, oh my goodness, I must have one because everyone's talking about them. And granted, I got them all from the same exact set. So I had 4 samples from the same, I think, 10-pack. But all 4 of them died. So I'd encourage you to always have spares. And if possible, I would encourage you to have spares, even of different types. So I think with the Omron probe I had, it was a normally open probe, so I crashed the tool head every time it failed, which is not very fun. So take that what you, I think the key is to order probes. I'd buy the PL05, PL08, and maybe an Omron. I mean, that's maybe $20 to get all 3 of them, or $25. And you can, yeah, that's hot. You can kind of see how it goes, but that would be my personal recommendation. And then do that probe accuracy test via temperature and see which one works best for you on your printer and your batch. Because ultimately, you have to remember that all of these parts are susceptible to variation in manufacturing and batch to batch. Like I want to say a little while ago, there was a supplier that was selling like essentially legit Omron. Sorry, let me take a minute here. So if you put this on like this is fine. It's not the best, not the worst. Actually, one moment. So I'm going to rotate. You want the block to go toward the front, I believe. So I'm going to wrap that around the back. Wrap that around the back. And then with this thermistor, it may make sense to route this the other direction, so it's not doing a 180-degree bend. Yeah, grab a couple, like really the data. So what I was saying with the variation is that, you know, one supplier may be getting legitimate high wind rails for a month or two, and then maybe after that they're like, oh great, you know, people think that we're selling high winds, and then, or maybe they get caught or something like that, and then they're like, we're gonna save $1 and swap to something else, or 10 million other reasons. Maybe they're, you know, they got a batch that were really good, and then they got a batch that were crap. You never know exactly what's gonna happen. So that's where your supplier kind of consistency is really important, and why certain, you know, why we recommend certain vendors on AliExpress, because, you know, the Photech probes or the Zongdi probes or Omnon probes, there's so many, you know, it's kind of a luck of the draw. Maybe even a good supplier, you know, had a good batch and then the next batch is bad. So I've dreamed about having essentially I've always dreamed about having like a review database of Voron related parts. So essentially, if you bought something, you'd say, I bought this in April of 2020. My X lead screw arrived bent or arrived straight, or it lasted 2 months, or, you know, all those variables will be really fun to get tracked essentially, so that over time we'd have a view of what sellers are good and what sellers are bad. So if you notice here, this wire actually is, the insulation has come off. So that's likely going to get replaced. But I'm going to keep assembling it now because I just want to show you how to do it. The other thing, so notice I brought in the wires, brought them around here, and then there's these 2 tabs here that are zip tie tabs for bringing the wires up. So typically I will do this like that, and then again that thermistor wire is coming straight out, so it doesn't have to do a bend. So your probe, which is right back here, is kind of protected, and everything lines up fairly well there. Zenbender, if you only have one guess, what's going to break? Can you give me more specifics? Break on a Voron printer, on a tool head, on plastic printed parts? Give me a little more specifics there. So on the hot end topic, everyone talks about the Dragon. What do you think? So if you know, if you guys know me, typically I will, typically my general rule of thumb is that, you know, if you can find something that is cheap and you know, does just as good of a job as something expensive, there's no need to spend money on stuff that doesn't actually make a difference. So, you know, at the same time, if there's something that does make a difference, like for instance going 24 volts and the 2208s, like that is a huge difference, and I highly recommend it. So all that's to say, I don't spend money on something unless I have to. And I was a great proponent of V6 for a while. I was testing the, what is it called? I was testing the Maxawatt hot end, or the heater block, which was really cool. One of my biggest gripes with thermistors was not knowing what type it was, and the Maxawatt looked great. It seemed like it has higher flow rates and stuff like that. It was just made sense to have a heater that surrounded the filament path to heat it evenly. So I was firmly down that path, and then essentially I had my heater block come loose, and my nozzle was wobbling around, making kind of weird print quality issues that I couldn't diagnose for a while. And then I just had a massive blob of plastic about the size this big that kind of consumed everything in the bottom of the tool head, including my probe, like melted like halfway across. And so it's one of those things that at that point I was like, I print enough that, and I'm tuning stuff enough that I don't want to ever deal with the hot end coming loose from the heat break. So I said screw it, and I have 2 dragons on both my printers. The V2.4 I will be building does have a V6, and I just want to print with the stock again, just because I'm trying to review the kit and see how things go. But down the line I'll probably replace it with the Dragon when it's on sale. If you browse the Discord, everyone is impressed with the Prusa i3 quality, and then that one uses E3DV6. So, and from a quality standpoint, I really don't think you'll see any difference between a V6 hot end and a Dragon hot end. For most things you're printing, there's just really not a significant difference in speed, in quality, as long as everything stays functionally together and stuff like that. From a flow rate standpoint, I think the Dragon and the Mosquito and those have a higher flow rate for their standard flow versions than the V6. But yeah. So that's I need to get some M3 by 16 screws, which I think this is actually one of them. So I'll go ahead with this. The other thing to note that's really key with the V6 is that you place thermal paste on the right side of the heat break. So you want the thermal paste on the heat break that is contacting the heatsink. You do not want any thermal paste on the heat break to the hot end. So essentially you want any heat that's in the heat break to immediately get conducted up to the heatsink. I did have some issues with my very first V1 build where I forgot to do that on a V6, and I had some issues. But that was also with eSun ABS Plus, which does have a slightly lower kind of glass transition temperature. So sometimes it makes a little bit, it's going to have heat creep before something that melts at 100 C. So that's not perfect, but it's close enough for me to demonstrate this. Again, I have not put in the 2 screws up here yet. The screws that fit right in, let's see if I can point to that, and the screws that fit right in here, they do not hold the hot end in place, so you do not tighten them after you install your tool head. They are only locating slots. The tool head slides up into those tabs, which prevent the tool head from going side to side, or like rotating side to side, or coming out too far. So you want them to be like tight, or you want them to constrain the tool head and not be super loose, but you don't want them to actually compress the tab at all. So that's one thing to note. But from this standpoint, and I have not put the probe in there either, but just trying to get a approximate view on where we are right now. So there is that. Again, the probe sits down here. Wires would be dressed up a little bit better, and then your cable cover, which is right here, if I don't drop it on the floor, will be back over here. So all your wires typically come up through and then back across, and then into your cable chain there. So I think that's about it for now. Granted, I haven't done everything to this, so it's not perfect yet. But it generally gets the idea down. I think I've covered most of what I want to for today. So if there's anything else, any other questions before I kind of end it today. Again, I do have these pulleys here, or these. I'll just throw these on because it'll take 2 seconds, and I was not able to do that yesterday. So again, we assembled the XY joints yesterday, except for these. So I'm going to loosen up the bolts here, and then slide this in, and then just drop this down in like that. And again, we're not going to tighten this bolt down entirely. We're just going to snug it up. And this will have some play up and down. It's but once it's under tension, it should self-center there. The reason why it has a little bit more play than you'd expect is because Gates idlers are slightly taller than these. I think these are Winson or just generic China idlers. So that is why there's a little bit more vertical room there than you'd think. So I'll go ahead and put this one on as well. So there's that. So as of now, we have most of the gantry kind of getting there. Probably on the next stream, we'll get the extrusions put on. We'll use these Z blocks here floating to mount those extrusions to the Z rails, which will be good. And at least we'll get the kind of as much stuff as we can mounted. Essentially, I think my plan is to mount the Y extrusions and the XY joints and the X-axis temporarily to the printer the next stream. I won't be able to put the rails on next, but as a reminder, tomorrow I will not be streaming because Uber will be streaming. I think he's doing the next stage of the V0 build, but just to avoid conflict with overlapping streams, at least I will not be streaming tomorrow night. There's always a chance that I do something during the day, but we'll just see how things go. But hope you enjoyed, and if there's no other questions, that'll be it for tonight. Thanks for watching.